Hello guys, let's start today. Today we are going to start a new project. What is our new project? Our new project is predicting. It's prediction, as I always get. Predicting concrete compressive strength. See, this is our new project. This is a good one, really a strong one. I absolutely love that. But before starting, we need our dataset. The dataset must be a clean one, and for that, let's absolutely give a lot of detail on that. Okay, I want a dataset to set my model on that. Can you give me the sites or the datasets? Okay, we can just wait for it to done the work. Until then, let's start our project. I need some music. Okay, that's good, we got it. We have found it on Kaggle. Okay, let's go always to Kaggle. We have it. Let's search in the Kaggle dataset. About dataset. It has 86 codes. Sorry, it's not important. We can always create another one. Let's see what we have. It has cement, slag, Flyash, water, Superplasticizer or PCE, and also another kind of data. Okay, let me download it. It's uploaded 7 years ago. I want to download it as a zip. Okay. We joined. Now download the dataset. Now we go to create our project. Let's go to our project and name it predicting concrete strength. Predicting concrete strength. But let's at first take a look at our dataset and see how we are going to name it. Let's take a look at it. Okay, we have CS megapascal. Okay, age. What is finger rate? Fine aggregate. Coarse aggregate. Superplasticizer, water, fly, cementage. Okay, this is the final column. Okay, we have it. Now let's start it by Gemini. I want to start a project on predicting concrete. Okay, what is the name? Concrete strength. What is the name? Compressive strength. Strength by neural network. Can you give me a good name for this project? and also the structure and map on how do this project. Also, I want you to help me create a report on my work. Okay, it's a good thing we ask it. Let's just wait. We have our data set. Let's wait for it to give it the name. Okay, both of the answers are pretty good, but I want the complete one. Because of that, I'll go with the choice one. The name's DeepCrete. It's a good name. I really enjoy that. This response is more helpful. Thank you a lot, Gemini. Okay, describe neural nets. Now we need to go to our GitHub and upload this project. Go to repository, new repository. Okay, description. For the description, we point this, choose public. Add license, we go with MIT license. Create repository. Now we have it. We now need to we need to open a new repository. Oh, we need to close this repository. How I can close it? Are you sure you want to remove? No, I don't want to remove it. Let me just commit them, the sites. No, I don't need to commit the sites. Let me discard changes, ignores. Okay, let's commit that, pull it. We need to close our past repository to create another one. Push to origin. Let me close Telegram. It's gaining a space. Okay. Now I think I can add the exciting repository. No. I need two. New repository. No, I want to have a repository from my disk. I suddenly forgot something stupid. Let me just commit this also. Just wait to fetch. New repository. Okay, I don't want new. Add a local repository. No, I want to add a repository from Git. Let me see if I close and open it. Any difference appeared? It's a problem. I don't know why I am coming from at clone repository. Okay, clone repository. I forgot that. github.com. We have first Git project. No, DeepCrete. Where the project DeepCrete go? Okay, one of them is Project-DeepCrete. This is the Project-DeepCrete. Okay, let's create our data. Call it raw data. I want to have our data here. Now let's go and see what it said on the way. Okay, project roadmap and structure. Phase 1, foundation, problem, objective to build a neural method that actually compressive of concrete based on considering an age, input features, output target. Okay, data collections, explore data analysis, understand your data, describe statics, mean, median, standard, mean and max, data visualize. Okay, let's go and start with phase 1. What for the report? Okay, let me just copy that. Create a report. Abstract, introduction, methodology, result, conclusion. Okay, let's start with abstract. We didn't know any abstract, background, problem statement, objective, dataset descriptions. Okay. Data preprocessing, training model, and training process. Okay, let me just copy that. Open new chat. Can you create these paragraphs on this site data and place the things you need more data to write empty. Okay, we are in. Before diving into creating our model, I want to do the analyzing right. Okay, let's see if it write it. Data set, inputs. Okay, data analyzing. And correlation heat map. A scatter plot. It goes up until methodology. Let me just copy that and write it here. Okay, data set descriptions, the UIC, input features, and target valuable data analyzing. Okay, we need some tables for the data analyzing. Let's start that. This section would be filled in after performing a Exploratory Data Analysis. Let's see which one of the text. Okay, key finding from EDA. This table would be plotted with descriptive. The text has some problems, I see. Let's see if I must delete that or not. This section would be filled in after performing a for exploratory data. You must write the text that I should copy and the other place that you can't write and you want me to write them. Just write the things you need, but bold the text I should delete. Okay, it's good. Let me control delete. Okay, let me just copy that. That's better now. This is here. It contains 130 samples. Let's take a look at it. Yes, it has. And also everything is good. Target variable, key finding. Describe the key finding. For example, mention which features had the strong correlations, if any outlier were detected, or describe the distribution of target variables. Insert your popular disruptive constants here. The table should include metrics like mean, STD. Okay, we must start our project officially now. Let's open our Anaconda. Writing a report is one of the hardest part of each project, but your project is useless without a report. The report is some kind of your core of your project. I write it wrong? How? Oh, activate tensor flow EMV. Okay, I done it right. Now Jupyter notebook. I don't know why I'm missing something like this, but it's happened. You just must continue. It's not the first time that happening to me, and not going to be the last time. Okay, we have our Jupyter notebook here. Now we have it. We can wait for it. Okay, go to desktop, project, dam failure, no, Project-DeepCrete, new file, data, analyzing. Okay, here we create a new notebook. And let me just copy the raw data. No, I don't want to copy that. I can open it from here. But I always say don't work on the raw data and always make a copy of that. It's useful, you understand after, because sometimes you do some changes on your raw data. You didn't want them to be, but the problem is that you can make them back. Okay, we have it. Let's start it with the easy sample to see if our kernel is working great. Now we have it. We must input our data. Let's rename it model data cleaning data cleaning. Let's see if we need cleaning. No, the better name is data analyzing. It's better. Okay, now we have it. Let's go to our data. At first we need to read our data. The data has no Flyash. Oh, it has Flyash. Okay, Flyash is something more useful. Okay, at first we need to do some research on the data. Let's go and open our data. Data is equal to, at first we need to import pandas as PD, then we need to, data is equal to pd.read CSV and the data name. It's wrong, I forget the name of data. Let's take a look. Concrete. At first, let me just put the data set site here at the end of the project. Data set site. So we're not accused of fraud. Just save it. Now we read our data. Let's take a look at the data. Okay, now this is our data. We go to Gemini, and not the Gemini we are using for the road. This is going to use as the structure. Let's create another Gemini. It's not a problem. Gemini. We have this data and want to get what the things that report want. This, can you give me Python code? Okay, we want to get the mean and the other things. Let's wait for the Gemini to done the work. Okay, it's the easy code. Let's just run it. The mean, the std, it have everything. Okay, I want you to give me this data in table. Let's see what it's going to give us. I must write here some code. Okay, let's see. The code that create a table. This misunderstanding always happened. Okay, let's give us the code. I think I know the problem. You gave me the code, the app that gave mean, std, and etc. I want you to change the code so that gave me the result in a table, not in terminal. Okay, let's try to, it gave us a result in the table, not in the terminal. Let's copy that and see the result. It saved the result here. Okay, we have the table it want. But the format of the table is not looking good. Let's open another Gemini. What the hell I'm doing? Can you make this data a good looking table for report? We just need to wait because that table is useless. Until then, let's commit something. No, we need to write a commit. Analyzing data. What is the difference between this and that? I can't understand. But let me just copy that. Okay, I need to design it a little. Let me just increase the size by hand. Okay, it looks better now. But the problem is that some of the results are not going as fine aggregate. Okay, fine. Fine aggregate, coarse aggregate, CS megapascal. Okay, Flyash aggregate. Let me just black it up. I don't know black it up. What does it mean even? Maybe this is a word I created. Okay, we have it. We just need to make it to look a little better. Okay, let me just make it a little here. And also, okay, now we have everything we want and it's a perfect way and the look is beautiful. Okay. Describe the K funding from your EDA here. What is EDA? Data analysis. Describe the K funding. Okay. Let's ask Gemini to write this. It's summary. Let's ask Gemini. Can you write this text by results I gave to you. Flyash, I think it's like this. Now we need to create this thing and also save the results as SVG in the new folder. You can name it, and also these are the headers. Let me just give it the headers. Paste as plain text. Okay, let it done the work. Now we just need to paste it here. K funding data. What the thing? I think I deleted something I mustn't. The K funding are going to go down here. Okay, here is the K funding. Let me just save it. And for the correlations heat map, we need the code that done the job. Why the hell did you want the CSV? I don't understand. You just must give me the code. Okay, as always, give me the code. We have Seaborn. Okay, let's run it. Name it heatmap for now. Map. Let's run it and make it markdown. Okay, I think it done the heat mapping. Output visuals. No, it's empty. An unexpected error could not convert a string to float. Fix the error. We just need the heat maps, and another thing to have a better understanding on the data. What is the problem? Oh, sorry, I gave it the wrong headers. Okay, let's copy that. If it's not work, I'm going to do some changes. These are the CSV headers. Fix the code. I think the problem is from the headers, but we can just wait to see. Okay, let's just wait. I think it fixed the problem. It's not running. I understand just right now. This space is not running. And it's not even deleting. Everything we created by just now got destroyed. Everything destroyed. Why the hell? Okay, we have this thing at least. It's the correlation heat map. Now we have the correlation heat map. What should we do? Go to report. Insert your generation correlation heat map here and discuss the relations. Okay, we must paste it here. Let me just copy that. Write this text for me. And let me just give you the correlation heat map. Okay, it's going to create the result for me. Now we have correlation heat map. Create the code for this. Oh, you don't have heat map. I now understand. You can get the heat map at SVG. Let's see if I can copy and paste you here. This is the heat map. Write it. Okay. Let's wait and see if you can read that picture. I hope so. Okay, I think you can. Now let's copy and go for the scatter plots. Let's save it. And let's save it. Scatter plot. We need to add new cell. Run it. The plots are created. Age with strength, 7 with strength. Now I can copy both of them and paste them here. Where are the pictures? We have the heat map here. Let's copy the heat map text. We have the heat map, and I don't want scatter plot. It's useless. Let me just delete that. Okay. Now let's take a look at the heat map and see what is said. What does heat map said? I hope you understand, but if you don't know, let's take a look at the data at first. We have 1000 C datas. Let me just commit everything. Analyzing data. Okay, let's take a look at the data. The data we have is count 1003, it's alright, we know that. The mean is 281, mean is 102, and max is 530. It's not important, the max is important for the megapascal. The mean is 2 megapascal and the max is 82 megapascal. That's pretty amazing. Okay, let's start to create our model. At first, we need to normalize it, or let's see what other steps that Gemini gave us. Data collections, okay. Phase through analyzing data, visualize, create a histogram for each of interest to distribute. We don't have to do them. Let's go to model development and training. We need data pre-processing, and let's go to methodology and continue their work. But before that, I'm going to end at data analyzing today and do the works in another lessons. Until then, have a nice time.